everyone, today I'm going to introduce you to a new MCP server that I have been working on over the last week called MCP HTTP AGENT.md. You might ask why this bizarre name is actually because of this new protocol that's used by a lot of coding agents called AGENTS.md. This is a file that stores the instruction for the agent. Usually stores things like the core ideas and goals of the project, the current progress inside of this project, best practices, and user preference for this project, so that the agent knows what stage of the project it is in and how it should behave. It has recently gained a lot of attractions by a lot of leading industry players like OpenAI with Codex, Google with Gemini CLI, and Cursor. Why using this is important, we should first let's take a look at one of the benchmarks for long context called fiction.live. Although nowadays a lot of models advertise that they have very long context lengths, like ChatGPT 5 with 400,000, Cloud and Gemini all have 1 million context lengths, you will see for most models that they will see a major degradation after just 16,000 context. This degradation means it will have a worse ability to retrieve all the context before this 16,000 context. At the same time, it also means less intelligence. You can have a try now at chatgpt.com. Try asking a very hard question with an empty chat or a chat that you have been chatting for quite long. You will find that the one with longer context, usually the LLM will become a lot lazier and in return becomes less intelligent. So context management is very important. So let's see how traditionally people manage their context. For our LLMs, you need a system prompt to tell like how should this LLM behave, what personality it should have, how should it output and format the response. Then you have your user prompt, like the question that you ask. In the case of the long context that we are talking about, most of the time you put your user doc or let it to multi-web searches. So this user doc can be very long, let's say a PDF or a paper from archives that was like 20,000 or 30,000 tokens in length, or like web searches usually is like 10,000 per search. You'll see your context fill up very fast. And keep in mind that LLMs don't have memory, so every time you send a new chat, it actually sends all the previous stuff back to the model. So if you have a long user doc or long web searches, maybe the first round of the chat is fine, but when you do multi-turn chat, it will fill up the context very fast. For chatgpt.com or some other traditional coding agent, what they usually do is when it hits this half context length mark, they will trigger a summarization for all the previous context into a compressed one, so that your context was low again. And you can chat again, and when it hits this half mark again, it triggers a summarization again. Of course, this is not ideal. For example, if you want to retrieve some very key details from your user doc, from a web searches, maybe like get the URL of a web page that it's looking at, or let's say you have some special instructions inside of your user prompt. After 1 or 2 times of the summarization, they will all gone. So you are lost the key doc infos through the summarization process, and it will even hallucinate on previous interactions. Let's say you said you don't want to use a package, but the LLM only remember about this package, so it might think that you want to use this package instead. And what worst part is that due to this compression, there will always be a considerable amount of context already be preoccupied. That means you are always not using the most optimum region for the context length, like the 16,000 we are talking about. So how does agent.md solve this problem for most coding agent? Agent.md stores the core ideas of the project and also track the progress of the current project. So let's say you have a long horizon task. Instead of needing to chat over and over forever until you fill up the entire context length. For agent.md, when you solve like step 1, you have one chat, and the agent reads the agent.md to know, okay, what we are working on, what it should do in step 1. And once step 1 finish, you simply start a new chat. So the agent only work on step 2. So the system prompt here usually just contains the generic system prompt provided by the API provider, and also how to maintain agent.md. And in agent.md, as we said, it has a very concentrated knowledge about the project, best practices, preference, all the requirements, and also the current progress of the project. Every time you start a new chat, it will always know what it's working on, and for the steps that they can isolate with each other, let's say adding a new feature to an existing code base, it can be done relatively easy because the previous step don't affect the current step. But this still have a problem. Let's say you are working on a very large monorepo. You need an agent to read some PDFs locally multiple times. Just using agent.md still fill up the context very fast. Let's say this is a very large user doc, like an entire paper, 20,000 or 30,000 tokens in length, then it also push outside this 16 comfort zone. That's what this MCP server trying to solve for like generic chatting applications. Instead of the main agent need to read all these heavy context use cases like user docs, web searches, and tool calls, the agent still get the agent MD and the user prompt, but instead calls our MCP server to separate these tasks per each small step into a lot of sub-agents. So only these sub-agents was exposed to this heavy context stuff. Let's say you have a user menu and you want to know how to turn on some function that isn't really viable with RAG because it has a lot of equation or a lot of code inside of it, then you just ask your sub-agent to read this entire context-heavy doc and write a small report, let's say 1 line or 2 line report back to the main agent. Also for searches, maybe you need to do a small deep research to know all the current models. For the main agent, maybe you need to search, for example, like models from OpenAI and Anthropic, DeepSeek, then this is already 3 searches taking 30,000 context lengths already. But you can ask a sub-agent to do that. The sub-agent can do this search or do necessary tool calls to finish that. And then with all this done, it just do a simple report with all those citations, let's say GPT-5 from OpenAI with a link to the OpenAI website. And with this concise report, it returns into main agent. So instead of the main agent going through all these searches and user docs, it only reads a report from sub-agent. So not only the sub-agent are hyper-focused because their contexts are isolated, they only focus one question and answer task, but the main agent will only see the concise report. So instead of seeing 20,000 or 30,000 tokens of doc or web search result, it only need to read report at most like 1,000 tokens. So in the end, let's say we have a system prompt that was around 1,000 tokens, a user prompt, let's say 200, 300 tokens, the normal agent.md with like 1,000 or 2,000 tokens, and the report with like 2,000 tokens. You can safely make the first response within 8,000 tokens. And if you spawn enough sub-agent to solve this task one go, then this step can be solved within this 16,000 token marks that we are aiming for. So that means the main agent does not suffer any quality loss and solve your task at hand. So with this out of the way, let's see how we should install this server. Go to the GitHub repo, move down. If you want to use Docker, then you use this one. People that don't want Docker but have npm installed, just use the upper link. Let's use the method without Docker. Then what you do is you pull out your terminal, paste it in. This will install our MCP server into your .config directory and create a default user account. Let's wait it a bit. So unfortunately, currently this script only works under macOS and Linux. We will seek if it's possible to run such stuff under Windows, but currently it's not possible. You will see the server started and it created a user. So this is our MCP endpoint. If you have been using Cloud Desktop a lot, you might be already familiar with this. You can already copy this to the MCP config. Remember to store your API key safely. If you serve this MCP server over network, anybody with this API key can access and modify your project. Please don't leak it. Other than the MCP too, there was also a UI available. Note that every time you want to start the server, you need to copy this command, run it start, then it will say UI available. Let's copy this UI and open it in a web browser. Let's copy the API key again, put it inside, save and continue. Now this is the project dashboard. But in case, like what we are demonstrating today with Misty Studio, we need to use this standard I/O method. So now let's copy this, go to Misty Studio, open the toolbox option, and when add a new tool, let's just import tool from JSON clipboard. You'll see it's like already imported. That's really good, and it will create an automatic toolset for us. Good. So after you add it in the toolbox, simply select it here in the toolsets and open MCP agent.md here, attached to the chat. And let's say we have a hypothetical oral exam for general relativity due in 4 weeks, and I wanted to let the AI become my tutor to walk me through this entire review process, answer some questions I don't understand. So let's say I have an oral exam for general relativity that will take place in 4 weeks, and I want to review all the important points inside of the lecture. So please create a project on that and guide me through all the important points and answer my questions along the way. Great, it looks good. Then we send. So let's see, ChatGPT has already generated a study plan here. So while it's still generating, let's go to here. You'll see we have a new project showing up in our web UI. It's called General Relativity Oral Exam Prep 4 weeks. We open it, then you'll see we have all these tasks that was generated by our agent, and you'll see the current in progress task that it has generated. It also generated one of the agent.md based on the example and the best practice that we have been talking about. You are always allowed to edit this. Let's say I really don't like that ChatGPT is not using LaTeX here. Of course, you can ask ChatGPT here to use LaTeX for its responses, but at the same time, we can also do things like this. The user wants to use LaTeX everywhere for math equations. Great. Then you simply save it, which with autosave toggle down, it's always autosave after you edit. You'll see that all the changes will show up in the history. Also, if you are not really happy with the task that it has created for you, you can edit the task here by changing the status. Or let's say we are already done with the first part. Let's move it to completed. And let's say we already moved to week 1. Okay, so it's already saved. And we go back to Misty Studio. One of the very good things about Misty Studio is that you can enable a context shield. So this chat was already isolated from all the future chats, which is ideal for our use case here since we want to keep the context length per each chat very low. If you are using some chat client that doesn't have this feature, simply just start a new chat and ask the model to check the project status. But since Misty Studio have this feature, we just turn on this context shield here. And let's say, hi, please read the project of reviewing general relativity, and let's get started with where we left off last time. Yeah, we can use this, and you will see that ChatGPT 5, after reading the updated Kanban board, it will know that we already moved to the phase of week 1 First, it will find the project, of course. Great. So you see, it already knows that we are in week 1 and knows what we are working on. You get the idea. So every time when you move to a new stage and you want to just keep the context clean, click on the context shield or just start a new chat. And you can virtually chat with this forever. So it can guide you definitely through one subject very easily. With that out of the way, let me show you some advanced use cases to use this MCP server as a tool for deep research using sub-agents. Let's create a new chat. So now, let's test a hypothetical scenario. I'm currently running a small business that I want to integrate LLMs into my custom support team. But I'm not so sure which model should I use. Can you please check all the new models that was released by labs like OpenAI, DeepSeek, Anthropic, Gemini to tell me like what new models are being released currently? And can you categorize and tell me where I can possibly integrate them into our customer support? Okay, great. Then we need to add some extra requirement. This is provided that you don't have a dedicated project for deep research setup, then you need to tell it how to use the MCP server for a one-time deep research. Let's say generate a project for that, and instead of doing search yourself, ask all the sub-agents to get the latest info for you. And then you just write a report based on their answers. Okay. Let's add one last task to ask how to deploy for enterprise. What is the best way to deploy these models for enterprise use case? Note that I'm currently located in European Union. Okay, so let's get Gemini 2.5 started. Currently, it is using one of our pre-configured models. So our pre-configured model was using Gemini with the official hosted tools like grounding with Google search, getting URL context, and code sandbox. We have some other pre-configured sub-agent like OpenAI with all the hosted tools, Grok with all the hosted tools, and OpenAI compatible with no tools. But at the same time, you can create one agent that use your custom MCP tools. We will not demonstrate how to do that here, but you can learn more with reading this README. So let's go back and see what it's doing. Okay, so it already created some sub-agents. Let's see what are they doing now. Okay, so it started with the agent. Okay, to find the list of the LLMs released by OpenAI, DeepSeek. Okay, good. Great, so it catched all the new models. DeepSeek 3.1, Opus 4.1, Gemini 2.5. Good. So OpenAI 001 and 03. It's strange, but okay. GPT-5, it's new. Okay. So let's see. Then it will proceed categorizing this model. Let's see. Based on model releases, modified. Okay. Their primary strengths is good. Okay, it gets a result. 01 and 03 is for thinking. Okay, potential integration for LLMs in customer support. Oh, okay, so it even gave me some use cases like intelligent chatbot. Good, multilingual support. I like that. Multimodal intake. Okay, it can also do this kind of job. Okay, good to know, I would say. Okay, so it get to the final report. LLM integration for customer support in European Union. So let's see. Okay, it has O1, GPT-5, DeepSeek R1, DeepSeek 3.1. Okay, Anthropic. Okay, Cloud 4, Opus 4.1, Gemini 2.5, great. Then it's categorized into reasoning, multimodal, efficiency, coding, good. And let's say, okay, how you should do it, like intelligent chatbot, multimodal, multilingual, multimodal, automated ticket, good. So what should we do? For GDPR, okay, we need processing, yeah, of course, I know that. So, well, it says, okay, data residency, good. Safety first. CRMs, okay, it's reliable, okay, regardless of this, good. Learn a little bit more about using that, good. Cool, so I have to set up data residency and stuff. I hope this gives you an idea about how to use context management to improve agents' research quality with the help of our MCP tool. Thanks for listening, and please feel free to check out our project and have a try to integrate into your own workflow. Thanks.